This is part 3 of the kinematics lab. For this part of the lab, the displacement between the two photo gates will remain unchanged and will be at 0.70 meters. However, the angle of the ramp is going to change, and we're going to use that to be able to calculate the velocity at that photo gate, at that second photo gate, and the acceleration as it rolls down the ramp. Okay, for this part of the lab, we'll only be using the metal marble. Station 1, the angle of the ramp is going to be 18.0 degrees. This is time trial 1 for station 1. This is time trial 2 for station 1. This is time trial 3 for station 1. At station 2, the angle is 21.1 degrees. This is time trial 1 for station 2. This is time trial 2. This is time trial 3. At station 3, the angle is 29.9 degrees. This is time trial 1 for station 3. This is time trial 2. This is time trial 3. At station 4, the angle is 26.9 degrees. This is time trial 1 for station 4. This is time trial 2. This is time trial 3. At station 5, the angle is 29.6 degrees. This is time trial 1 for station 5. This is time trial 2. This is time trial 3. At station 6, the angle of the ramp is 32.6 degrees. This is time trial 1 for station 6. This is time trial 2. This is time trial 3. This is time trial 1 for station 7. This is time trial 2. This is time trial 3.
The Kinematics Lab Part 3 Angle versus Acceleration Calculations. So, if you use the data from the video, this is the data that you should have gotten. So now what we're going to do is we're going to use this data to calculate the acceleration as the angle increases. So once again, these are the kinematic equations that we're going to use and those variables. Now, this is what we're going to do. We're going to ask ourselves these 3 questions. Which variable are you being asked to find? What 3 variables do you already know? And which equation has those 4 variables? So let's do station 1 for part 3. So a marble starts at rest and accelerates uniformly over a time of 0.7925 seconds for a displacement of 0.700 meters. Determine the acceleration of the marble during the time interval. Then calculate the velocity of the marble at the end of the time interval. So the first thing I'm going to ask myself is, what am I being asked to find? And I'm asked to find the acceleration. Right? Then I need to ask myself, what 3 things do I already know? So I know the initial velocity is 0 because it starts at rest. Then I know the time interval, the delta t, is 0.7925 seconds. That is the average time from those 3 time trials. And I know the displacement, that delta x, is 0.700 meters. So I can go ahead and just keep track of those down there. And then I'm looking for the equation that has these 4 variables. And it's going to be the second one. So I can go ahead and plug everything that I know into that equation, and then I can solve for the acceleration. So I get 2.63 meters per second squared. Now notice my answer has three significant figures because it is limited by my least accurate measurement, which happens to be that delta x, because that delta x has three significant figures. So my answer has to have three significant figures as well. Then I can calculate the velocity. Now I could use any three of these equations. However, I'm going to use the third one because even if I calculated the acceleration incorrectly, or there was something wrong with the the setup, I can still get that final velocity. So I get zero. So this is what I get, and I can just solve for that final velocity. And I get 1.77 meters per second. Notice I have three significant figures. So then what I can do is I can go ahead and plug that acceleration into the data table, and I can do that for the remaining 7 stations. So once again, this has been the Kinematics Lab Part 3.